Hi, welcome back to Leetcode. So in this video, I'm going to discuss Leetcode problem 3543, maximum weighted k-edge path. So the problem statement is that you are given an integer n and a directed acyclic graph with n nodes, okay, labeled from 0 to n minus 1. And this is represented by a 2D array edges, where edges I represent ui and vi and wi. That means what? So this is directed acyclic. That means we have an edge from UI to VI. And what of this edge is WI. Got it? So that means indicates a directed edge from node UI to VI with weight WI. You are also given two integers k and t. K and t. So what is k and t? Your task is to determine the maximum possible sum of edge weights for any path in the graph such that the path contains exactly k edges, and the total sum of edge weights in the path is strictly less than t. Okay, and we have to return the maximum possible sum of weights for such a path. If no such path exists, we have to return -1. So our by default answer is -1. And when actually we will check this is still one valid answer or not. So that means suppose we actually have some this graph. So this is node 1 2, another node, okay, 3 4. So we have to suppose we are starting from here, node 1, and we have reached 4. Okay, so 1 to 4 ultimately. So we have this path. First we will starting from 1, then 2, then after 2 to 3, then 3 to 4. This is the path. So in this path, exactly k edges. So how many edges are here? Actually 3 edges. One is 1, second is third edge. Correct? K is equal to here 3. Suppose, and the total sum of weights in the path is strictly less than t. Suppose this is x1 weight is directly x2 directly x3. So what is the total weight of this path? That will be x1 plus x2 plus x3. Correct? And this will be valid answer, possible answer, not maximum. One possible answer if it is less than t, whatever the t actually it is given. Okay, so if it is less than t, that means this is one possible answer. So what have to do? We have to find out all such such kind of path where actually we actually have exactly k edges from u to v. Any, we can start from any u and we can reach any v. Now we have to find out that to reach from u to v, this is directed acyclic. So from to reach from u to v, we actually have exactly k edges. Okay, first condition is this, that we should have exactly k edges to reach from u to v. And the next condition is that what is the actually weight of this path from u to v, whatever the path actually we have actually traversed, the total sum of that weight should be less than t. Less than t. Got it? Clear? Then this is one possible answer. Correct? And if there is no such path, then we have to return -1. So let's go to the example 1, what actually we are trying to do. So that means here actually you can see that here n is equal to 3. So that means we actually have 3 nodes, 0 1 2, 0 to n minus 1, and edges are there, 2 edges are there, 2 edges. One is from 0 to 1. You can see that here actually 0 to 1, or weight is 1. From here actually u v w is 1. Got it? Next edge is from u 1 to 2, 1 to 2, and weight is 2, and k is equal to 2. That means what? We have to find out one path from u to v that should have exactly 2 edges to reach from u to v, and the sum of the weight to reach from u to v, sum should be sum of weight should be less than t. Okay, so first of all find out all these such kind of paths, valid paths. So suppose I want to reach from 0 to 1. Suppose u is 0 and v is 1. So we have to find out all the path. So from 0 to 1, so there is only one path here and weight is 1. So weight for this path is 1. Okay, so this is less than here is what is t? T is 4. Yes, less than t. Got it? This is correct. Another condition was that the how many edges are there actually? Only one edge for 0 to 1. So we have to, what have to do? K is equal to 2. That means we should have exactly 2 edges, but this is only one edge actually I am. So that's why this is not a valid path. Okay, is there any path to reach from 0 to 1? No. Okay, so from 0 to 2, So what is the path actually we can reach? First we can reach from 0 to 1, then 1 to 2. So what is the sum of weight? Sum weight is first is 1, next is 2. So total weight is 3. So this is less than t. T here actually 4. Okay, one condition is it is specified. Another condition is that the number of edges. So how many actually edges are there? One is, this is the first edge and this is the second edge. So two edges are there. So this is equal to k. K here is 2. So both are actually satisfied. So this is one possible answer. So what is the weight? Sum of the weight 3. This is for 0 to 2. Correct? To reach from 0 to 2. Next, I have to search from 1 to 0. Is it possible to 1 to 0? No, there is no such path. We can't reach from 1 to 0. So okay. Next is 1 to 2. So 1 to 2, there is only one path. So what is the weight? Weight is 2. So that is less than t. Okay. Another condition was that the number of edges to reach from u to v means 1 to 2. That should be exactly 2. Means exactly k. Here actually k value is 2. So that's why I am saying 2. So there is, but here actually only one edge is present. So this is not a valid path to reach from 1 to 2. So there is no another other such path to reach from 1 to 2. So next is, what is the valid possible node actually I can take from 2 to 0. If I start from 2, I want to search that is there any valid path to reach to 0. So there is no such a path to reach from 2 to 0. Okay. Next is 2 to 1. 2 to 1, no, there is no outgoing edges from 2. So there is no such valid path. So there is only one valid path. So that's why here actually answer will be 3. Got it? Why output is 3? Clear? Next is example 2. Example 2. So we actually have again 3 nodes, 0, 1, 2, and edges are here from 0 to 1. From 0 to 1, the weight is 2. Another node is present, another edge. So that is from 0 to 2 and weight is 3. Correct? And the k is equal to 1. So I should have exactly one edge between u to v. Okay, and the weight should be less than 3, less than t. Here t is 3. Clear? So first of all, I will find out that is there any path from 0 to 1. 0 to 1, yes. So there is this edge is present. So weight of this is 2. So this is less than t. T is 3. So this is one valid. Another condition is that we should have exactly k edges. So here actually how many edges are there? Only one. So that is equal to k. Here actually k is equal to 1. So this is one valid path. So one possible answer is 2. Okay, first of all find out all the possible answer, valid answer. Then actually we will take the maximum out of all of them. So next is I want to find out is there any path to reach from 0 to 2. Yes. So this is the path. This is the path I can go 0 to 2. The weight of this is 3. Correct? So this is less than t. No. This is equal to t, not less than t. So this is not a valid path. Correct? So we don't need to check the another condition, because only we have to satisfy both the conditions. So if at least one condition is not valid, so that means this is not a valid path. Next is I want to reach from 1 to 0. There is no such path from 1 to 0, right? So there is no possible answer. So now I want to reach 1 to 2. There is no such path. Next I want to reach from 2 to 0. 2 to 0. 2 to 0. There is no such path. From 2 to 1. There is no such path. Okay. So there is only one answer. 2. So that's why here actually output is 2. Got it? So here actually you can see that for example 3, n is equal to 3. So that means there are 3 nodes. You can see here 0, 1, 2. 3 nodes are present. Edges from 0 to 1, weight is 6. Another is from 1 to 2, weight is 8. Okay. So now k is equal to 1 and t is equal to 6. Suppose first I want to reach 0 to 1, then another path I want to explore from 0 to 2, then I want to explore 1 to 0, then 1 to 2, then 2 to 0, then 2 to 1. Correct? First of all, find out 0 to 1. So there is yes one path I can reach this in this edge by using this edge. So the weight of this is 6, and this is equal to k, number of edges, only one edge. So this is equal to k. K value is here actually 1. So this is the first condition is satisfied. Next condition, what is that? The weight should be less than t, sum of weight. But here t is 6, but however here actually the weight is actually 6. So this is not less than t. So this is not a valid path. Next is 0 to 2. 0 to 2, yes, there is one path. First I will reach 1, then 1 to 2. So the sum of the weight is 6 plus 8. So this is 14. So first condition is that we have to have exactly k edges. How many edges are there to reach from 0 to 2? 2 edges. 2 edges. So this is not equal to k. So this is not a valid path. We don't need to check the next condition also. This next condition also, this is not a valid. Okay. Now go to the 1 to 0. 1 to 0, there is no such path. So there is no such valid answer also. From 1 to 2. From 1 to 2, yes, there is a path. This path, and weight is 8. That is less than 6. No. So this is not a valid path. Next is 2 to 0. There is no such path to reach from 2 to 0. And 2 to 1 also, there is no such path. So there is no possible answer, valid answer. So that's why we have to return -1 here. They mention that if there is no such answer, valid answer, so we have to return -1 by default. So what is the brute force approach we can actually think? Brute force approach. So first of all, I will explore all the possible paths starting from suppose u. Okay. So u will be from 0 to n minus 1. The range will be from 0 to n minus 1. Now I know the all the edges that is present. I can actually go from u to v. That actually I will make the adjacent list from that edges vector of edges. Now I know that I can reach this v1 suppose and v2 in this way. So I know that what is the weight on, and this is what is the weight for this. Now I am starting from this node u. So what will do? I know that initially node is 0, weight is 0 till now to reach to u, because this is a starting node. And the how many edges I have used? 0 edges. Okay. Now what is I can do? I will go to this path first of all, go to v1. So the weight to reach for v1, if I start from u, so what will be the weight for this path? That will be 0 plus w1, correct? And how many edges I have used? 1. 0 plus 1, correct? Because I have consumed 1 edge. Now in this actually, suppose from v1 actually I can go to v3 suppose. So what will do? I will come to this node. So what will the weight for this? Suppose this is the weight 3 suppose. So this weight will be 0 plus w1 plus w3. This is the weight for this path to reach from u to v3. Okay, and how many edges actually I am consume? 0 plus 1 to reach v1, then another edge. So this will be again plus 1. Got it? And I will check that whenever I reach a new node, I will check that whatever the actual weight actually I have, this is the weight, sum of the weight for this path starting from u to current v3, any random node. So I will check that if the sum of the nodes is less than t, okay, sum of the this sum, and also the number of edges actually I have used that is equal to k, then this is one possible answer. So I will store this. I'll compare this, whatever actually sum of the weight actually I have with the global answer variable. Initially it will be -1 because by default answer will be -1, and I will check that if this is a valid answer, then what I have to do? I will compare with this whatever I have to take the minimum. What do I have to take? I have to take the maximum sum. So I'll check that what are the sum actually I have in this path to reach v3 from u. So it is maximum or not. First of all, I have to check that this is valid or not. How is it check? I actually have the sum of the weight and the number of edges I have used. If it is less, the sum of it is less than t, and the number of edges I have used that is equal to k, that means we have reached one valid path. Then actually we compare what are the sum actually I have, that is maximum or not with, and if it is maximum, I have seen till now, that I will store in the answer variable. Correct? So this is a brute force approach, DFS. So I'll start from each node. First I'll start from 0, then I'll start from 1, explore all the paths. Correct. Now what is the time study for this? First of all, I am starting from u and the range from will be 0 to n minus 1. So this will be big of n. Correct. And for each starting node, I am trying to explore all the nodes I can actually reach if I start from u. Correct. So the time study again will be big of n because I am trying to visit all the nodes I can reach from u. So this will be n square. Correct. Now why it will be n square? It may be actually greater than n square. Why? Because it may possible that something, suppose in this way, Suppose this is actually v1 and this is v2 and this is actually v3. So this may be possible, like suppose in this some way, in this we've reached here, and in some other path actually I've reached v2. So I can again explore v3. Got it? This may possible. Again actually I will explore v3, then the hierarchy below this v3, this will again explore. So this will be actually exponential. You're going to think about this because it may possible. Now how will I optimize this? So instead of DFS, if I use BFS, then it will be optimized. How? Because I know that I have to find out only maximum k edges. Maximum k edges, I know that because I don't know that what is the maximum weight for k plus 1. So what is the BFX I can do? So I will start from all the nodes from 0 to n minus 1 because all are actually possible valid starting node. Okay, then I will check that by using extra one edge, for example, I can reach from 0 to suppose v1 v2. Okay, suppose. So I can actually from 0 to v1 I can actually reach by using one extra edge. Suppose this edge is w1, weight is w1, another is w2. So what I will do, I know that what is to store, I have to store that for the starting this node u, for this node u, by using how many edges I can reach, what is the weight actually possible, because I don't need to know the how many ways. I want to know only the maximum weight. So it may possible that two different ways actually, two different paths I am getting the maximum same answer. So but we need to count only once because we don't need to the how many paths actually I can actually reach that maximum weight sum. Correct? So that's why what we'll do, I'll store that for this 0 to n minus 1, for this 0 to n minus 1, by using I edges which weight actually possible to reach 0. Okay, that means what? Suppose 0, this is the node 0. So I want to know that by using I edges, what is the weight is possible to reach 0. Suppose in this path I got that w1, by using total sum is w1, I can by using I edges I can reach node 0. Another path is present, this is the second path. Suppose by using I edges, same edges, I can by using weight 2 I can reach node 0. I am storing all unique weights to reach this node 0. Okay, now what will do, next I will do that for I plus 1, this is actually I have reached by using I edges. Next I want to know that if I use extra 1 edges from 0, what actually I can reach. Suppose I can actually reach 1, another reach 2, suppose. So what I will do, this weight actually I know this weight is w1 by using I edges. So next what will be this one actually I can actually reach, this will be I plus 1 edges because I know that this is ith edges, I number of edges I have used, and what will the total for this? This is suppose weight x, suppose. Then what is the weight for to reach w1 sorry node 1? That will be w1 plus wx weight I can reach from 0 to 1 by using I plus 1 number of edges, and the weight will be w1 plus wx I can reach from 0 to 1. Got it? So in this way, ultimately after exploring like from 0 to k number of edges, I actually have all the weights actually I can reach 0, 1, 2, all the nodes actually I can reach. Okay, I know that this is actually the final node I can reach here. So now what I have to do, I will iterate all of this, and what I will do, I will check that for this k number of edges I have used here, and what is the, if I sort all of the weight actually I can reach, suppose w1, w2, here actually you can see that I have used actually 2 weight I can reach node 0. Suppose by using k edges, k number of edges, I have reached node 0. So I actually have w1, w2 in the k number of edges after using k number of edges. So what do you do? I will sort this w1 and w2. Suppose this I got this sorted. So w2 will be the maximum weight after sorting. So this is one possible maximum value. So I do not need to compare with W1. I need to only check, because I have already sorted. I know that the whatever the last number will be present, that will be our one possible maximum answer. So I will compare this with the answer variable. Okay, this is for each node. That means I will check that what is the weight is possible to reach uh, node 0 by using k number of edges. Okay, next then I will compare that what is the weight the possible to reach node 0, and I will sort this and I will compare with the last value with the answer. Next I will go to the next node I is equal to 1. Then suppose I got another w3 w4, and this is the possible weight to reach node 1 by using k number of edges. So now what will do, I will again sort this whatever the weight is present here, and I will compare this w4 with the answer. In this I will explore I is equal to, from I is equal to 0 to I is equal to n minus 1. Got it? In this you can see that I am not exploring like all the paths. I am only exploring the unique weight plus unique number of edges. That is important. By using unique number of edges and unique weight, I can reach the this destination node that I have to store. If it is same number of edges, by using same number of edges and same number of weight, if I reach here in this node, do I need to explore these two paths? No, because again it will be the same weight. Suppose again this is W1, this is W1, and this is W2. If I reach this if I want to explore this node next time, so that will be again W1 plus W2. This will duplicate. So that's why we can actually discard this, because but that should be what, using same number of edges. Suppose here actually got I number of, here actually jth number, then it is different, not same. I can't actually take this is same, both are actually same, because it may actually lead the maximum answer in future. So that time we have to explore both the things. Got it? Now if you any doubt, any suggestion, you can comment on that, and I hope this is clear. Now go to the code, then it will be more easy to understand. So first of all, I have to store a dp vector distance. What actually I'm storing? I am storing that to reach this destination node I, and this number of edges, I number of, suppose kth number of edges I have used, what is the different weight is possible to reach this ith node, correct? So this will be I, suppose u, k number of edges I have used, and what is the weight are possible to reach here. So got it? This is dp. What is I storing? I am storing this in this destination node by using this current number of edges, means k number of edges. What is the different weight actually I can reach? Different weight, because there are multiple weight are possible, so that's why we have to calculate it. Now, so how many nodes are possible? N number of nodes, and for each node how many actually edges are possible? K. So that's why maximum k number of edges I have to explore. So that's why I make what is the size of this? K plus 1, because 0 to k. Got it? And initially all are actually empty. Now what I have to do? I have to create the adjacent list from these edges. So there actually n nodes are present, 0 to n minus 1. So that's why size is n. And there can be a pair, because this is directed graph, and also this is actually weighted graph. So that's why there will be one weights also. So that's why I'm just traversing the edges. I'll get u. So in this u, I'll store the v and the weight. So that's why I'm storing e1, that is the v, destination node actually I can reach, and the weight of this edge. Got it? E2. Okay. Now I've created the graph. I actually have the graph. Now initially what will be the initial state? Base case is that by using 0 number of edges, we can actually reach only 0 distance, 0 weight. So that's why initially what I'm storing, that for each node 0 to n, I can actually, by using 0 number of edge, I can actually reach only weight will be 0, because I do not have any edge. So that's why weight should be also 0. So that's why for each because, and also why actually I'm storing all the nodes, because all are actually valid starting nodes. So that's why for each starting node I have to explore. So that's why I'm storing this for each I is equal to 0 to I less than n for each starting node, and k, this is the second 2D array. So second is the number of edges I have used here. Here actually 0 number of edges I have used, and insert means I'm storing the zero number of actually I have reached here. Got it? Next is starting from 0 to k, that means 1. Previously I have actually have 0 number of edges I have used. Now what I have to do, 0 plus 1, next number of edges, because I have used 0 number of edges previously. Here actually when actually I'm storing here. Next is I am trying to consume one more edge, and then actually check that where actually I can reach and what will be the weight for that. So that's why I'm starting from I is equal to 0 and I less than k. Why? Because suppose I is equal to 0 and k is equal to suppose 1. I want to consume only one edge. So if I add one edge, then actually I actually have suppose v, then actually I have reached k is equal to 1. So that's why I am going up to less than k, not equal to k, because when I have the k minus 1, then I am consume one more edge, then actually reach k number of edges. Got it? The logic. Now what I'll do, I can actually start any node. So that's why I'm starting from each node, j is equal to 0 to j less than n j plus plus. Now what I have to do, I know that from this current node 0, suppose in this example 2, I can actually currently I'm in node 0. So how actually I can reach node 1 and node 2. First of all, I try to reach 1. Okay, so I am consuming one more edge, that weight is 2. And what is the weight to reach 0? So that will be 0, because this is starting node. And I'll check that what is the different weight actually I have, that is 0. So particularly this current node j, you can see that j is the number of node, the node number, and I is the number of edges I have used. So this is 0 now. And the how many actual weight are there? Only one node, one weight will be there, that will be 0. So new weight will be what? Whatever the weight for this edge, that will be 2. So that I will get from this adjacent list edge, correct? E dot second, because first will be the v and the next will be the weight. So that's a new weight will be the a is to this distance to reach 0 by using this number of edges. Got it? And when it will store for the next round, next k plus 1, if it is the whenever the new node or new weight for this path is less than t, that should be strictly t, then I am going to store for the next number of edges. You can see that if it is less than t strictly, so, and I have already validated that this should not be this will not cross k, because I am only running from 0 to k, less than k. So this is sure that this condition will always valid, the first condition, that the path contain exactly k edges. Okay, will not cross k. This is sure. In the next, I have to ensure that the sum of the weight should be less than t. So that's why if it is less than t, the new weight less than t, then I am going to store for the next next number of edges. So you can see that e dot first means v, u to v, I can reach v. So this is going to the next. So distance for that node, I am going to consume one more edge. So that's why this will be for I plus 1. Next, next number of edges. Got it? And what will be weight of this path? This will be new weight. Got it? In this way, actually, I have explored all the paths by using the BFS. You can see here that I am first trying to explore that what is the weight actually I can reach from by using only one edge. Then I am trying to explore all the weight actually I can reach to all the destination by using two edges. Next is for 3 edges. In this way, I go up to k edges. Got it? And I actually have all the weights to reach to this destination in this particular k number of edges by using k number of edges. Got it? Now what to do? I actually have the this list, right? How actually the weight, different weight, I can reach the different nodes by using k number of edges. Now initially our answer will be -1. This is a default answer. So for each destination node, I have to check that is there any path, valid path or not to reach this particular node by using k number of edges or not. So how actually you can get this? I will get from distance this vector, and first will be the destination node, current node, and the k is the number of edges I have used. So I am iterating from I is to 0 to I less than n, because each can be the destination node, because it can be start from anywhere and this can be end anywhere. So that's why I have to check all the destination. So I'll check this particular destination, destination node. If there is some valid path, means that is not empty, correct? So this particular ith node, k number of edges, if it is not empty, that means we have some path, valid path. So I'll compare this, whatever the last value is present, because this is set, ordered set, so the maximum value will be stored at the end. So I'll take the last value and I'll compare this with the answer and ultimately return the answer variable. What is the value actually I have? Suppose if there is no valid path, so this will be always empty in this case. Suppose in the example 3, it will be always empty. So it will be by default answer it will be not modified in the line number 33. So it will be written minus 1. Got it? So I hope this is clear, and I have shared this code in the description. You can check that. And thank you. And if you're not yet subscribed, please subscribe channel. Okay, bye.